All right, today we are talking about chapter 10, introducing the concept of functions. So this is how you create code that is reusable and let it make your code more efficient. And I'm going to give you lots of examples of this today. So I'm going to talk about this concept of a black box, which is a kind of a good way to think about how a function works. Then we'll talk about some of the familiar functions you've already seen and have even been using, even if you didn't realize it. This concept of input. I'm going to go over what parameters and arguments are. I've mentioned it before, but I want to talk about it in the context of functions now that you're learning how to write them yourself. And then output, do you return values? Do you not return values? Because you can have functions that do either. The concept of variable scope, I've mentioned that somewhat in passing before, but we're going to really talk about that today. And then, what does it mean to compose your functions and think about how you want to, divide up and arrange your code, and some strategies for that. And just, why functions are awesome. And then when we get done with that, I'm going to do a little demo for you of a short program that, as it currently exists, is just run from top to bottom. It has no functions. And I'm going to transform it. And you're going to watch how functions are going to clean up the code and make a lot of it, reusable and very, very useful in a larger context. Okay. So let's talk about this black box. This harkens all the way back to when I was, I think, in high school, and I had a math teacher who talked about this with, writing functions with math. This idea that you have, a box, you put something in, you get something out. And no matter what value you put in, you can rely on the fact that you should always get consistent results with whatever's going on inside the box, even if you don't know what that is. So let's say we have a box and we have a number of values. We put in 3, we get out 9. We put in 5, we get out 25. We put in 9 and we get out 81. What's going on inside that box? Can somebody tell me?
Squaring.
Yeah, we're squaring it. So we give it a value and we get a result every single time, no matter what value we put in. But we have a process that is reusable and we can, count on what's happening. So again, I've got another box, and this time I put in, pig, and I get capital P space capital I space capital G. I do the same thing with fox and cat, and I get it formatted the same way every single time. So while you can sit here and just look at it this way from the input and the output and then guess at what's happening inside based on the results, we're going to turn it on our head, because you're actually going to get to write what is happening inside the box and make it happen. So some of the functions you're already familiar with would be things like the number and string and Boolean functions that are built into JavaScript for converting types. In graded assignment 1, you've already seen some of the functions where you're placing your code that LaunchCode provided for you, like ask question and grade quiz and run program. You've used functions that are attached to objects, like string and array methods, pop and split. I've got, I guess, results on all of these. Yeah. So there we go. So, pop, it does something for you, right? It removes an element from the last index, and that's a permanent change, but it also returns a value. It does something and it returns a value. So it does both. Split just returns an array that gives you all the characters of the string divided out. Another function you've been using is question, which is part of the readline sync library, right? So we ask the user how many cookies, and 2 different things happen. First, it prints something to the console and gives the user a chance to respond. And then when they do respond, it returns that value so that you can use it. So that's a function. And then the console API, there are lots of different methods that go with the console that you're going to learn in the future, but log is the one we use constantly, right? And we give it hello, and it prints that to the console for us, right? So we've been using functions. So now we're going to define them yourself. So let's talk about the anatomy of a function, the terminology associated with it, so you can start to get comfortable with that. You always use the keyword function, and for a basic function. And in the future, in chapter 11, we're going to learn a couple of different ways to do functions, in addition to today, but we're just focusing on a regular named function. So you will use the keyword function, and you're going to give it a descriptive name, using camel case. So usually it's some sort of verb or noun combo, like that makes it very clear what the function is supposed to accomplish. And you must have a parentheses to follow the name. And if you don't have any parameters, it's going to be empty. But otherwise, anything that you need to pass in, that input to the function, you would put that inside those parentheses. And then any code you want to be executed when the function is used goes inside that function body. Okay. And then there is a return keyword that is optional. It depends on whether you need the function to return a value or if you're just letting it go accomplish something for you. So keywords are function and return. The name of the function there, we have greet user. We're, saying exactly what this function is supposed to do. We have a parameter in this case where we need to pass in a name so that no matter what the name is, it can use it. And then we have the body, the lines of code that are supposed to execute when we actually go to use the function. Now, so far, what we have done here is define a function. We've just said this is what we want the function to be and to do and to have a name, but we're not actually executing any code yet. So there's a difference between calling a function and defining a function. And this is a very important distinction to understand if you're going to get very far with these. So you can define a function anywhere in your code. Up until now, everything you've written has been running from top to bottom, right? It executes code from the very top of the file to the bottom. However, when you define a function, you can put that anywhere and use it from anywhere. JavaScript actually, in the compiling process, before it executes, will go through and find those functions and make it available to anywhere in the file. So I'll demonstrate that for you. But defining it does not execute that code inside the body. The only way to do that is to call the function when you're actually ready to use it. So you're defining it and setting it aside and say, okay, I want this code to be available when I need it. But you have to actually call the function for it to run. It's an easy mistake to forget to do that, especially when you're new at this. So I just really wanted to make sure you're clear on the difference between the two. So in this example, I'm actually calling these functions up top. I'm saying, calling say hello, and I'm passing in the name Joe. And here I'm, calling a function called format email and passing in joe@schmo.com. And so the functions themselves are defined elsewhere, and you can actually see, them here where we say, okay, I want to create a function called say hello, and I want to allow it to take a name and then console log hello name. I also have another function, format email. I want to pass in an email address, and no matter what it is, I want this string to be returned that will say email address : space and then give the email. And so in the first case, we're calling the function say hello. It does the printing for us. So we don't have to return anything, right? And I'll go over this again in a minute. So we're just calling it. But here we call the function, but it's returning a value. So then we have to actually print it at that point if we want to see it. Otherwise, you might be storing it in a variable or something like that. I'm going to go over all the different possible ways you might call functions in different contexts for different purposes. But before I do that, in terms of showing you different ways to use the functions, let's look a little closer at this concept of input. Okay, so when you are defining a function, parameters are actually variables that you're setting up. So those parameters will just represent whatever data you want to pass into the function. And you're going to use some descriptive names. You'll do it with camel case, like most things in JavaScript. And they essentially just are established as local variables, which means they can be used anywhere inside that function. They're not available outside, but they are available inside. You do not need to use the let keyword to do this. It automatically creates them for you and gives them that scope so that they're only available inside. So here's a very useful example. I've actually written something like this for a job where I had to, I was dealing with people's credit information and financial information. So let's say we're going to format the social security number. We can take in the 3 parts. Let's say that's how the data is given to us in 3 parts, but we want it to actually read nicely with the hyphens and stuff. So we create a function that just says format the social security number. And then we say, let's create 3 parameters to represent whatever those values are for the 3 different parts of a social security number. So I'll have SSN1, SSN2, and SSN3. And then I can use those as variables to take the place of whatever real information might be passed in later and say, let's just format that with dashes in between them, right? This would be one way to do it. You also could just use join with a hyphen, right? And just return that. So there's more than one way to format it, but these are parameters, SSN1, SSN2, SSN3. They're just variables that represent whatever data would be used. When you go to call the function, this is where you actually have real values. So I can pass in 1, 2, 3 for SSN1, 4, 5 for SSN2, and 6, 7, 8, 9 for SSN3. And now we actually get a real result with those values. And those are called arguments. Sorry, let me go back. Yeah. So let's look at this again. So it's on this slide. Those are called arguments whenever you actually have real values that are what the parameters are representing. So here's another example. When you call the function, pass in those arguments, and you just want one for each parameter, you do need to do them in the same order that the parameters have been defined. So you have to be aware of what the function definition is so that you can follow it. And so if you have a format date function that the parameters here are weekday, month, day, and year in those formats, make sure you pass them in that way down here where you have Friday 10/07/2022. And it'll return it formatted the way you want. So if I actually were to create a variable and say I want the formatted date to be whatever comes back, whatever's returned from this function, I'll call the function, pass in my values for each of those parameters, and then the result, this value that's returned actually is going to be stored now in formatted date. So if I console log formatted date, I can see the result, which of course is Friday 10/07/2022, just as we designed it to be in the code that's in the function. But it doesn't happen until we run it. But that's how you distinguish between parameters and arguments. Okay. I would like to live code some things for you before I talk more about other ways to do parameters and arguments. So let's go over and do some things. We've already got a way to ask you for user input. We'll use that later. But for now, I want to define a function. I'm actually going to do it below because I want to demonstrate for you how this works, where JavaScript doesn't care where you put the definition. It can use it from anywhere. So I'm going to say, let's do say hello, pass in a first name, and then this function's job, it has one job, and that's just to print hello, first name. Okay. So the function exists. Right now, if I go to run this, nothing happens, right? I have defined the function, but it is not going to execute this code unless I actually call the function. So up here, let's call it. I'll just call hello, say hello, and pass in link. Okay, now I'll run it again. And it says hello link. So we ran the function and it printed exactly what we expected it to. All right, now let's run a function that's going to return a string and it's going to describe one or more enemies. I'm going to give this describe enemies will be the name of the function, makes it very clear what it is it's supposed to do. I'm going to pass in three different things. So I need three parameters: enemy type, the number of enemies, and the action verb, so that you can, be a little bit, have a different result each time with the verb even, not just the names of the enemies and how many there are. So I could return something that says, A, and then have enemy type is, and I could just say action verb nearby. Okay. And so I could actually call this with a real value. So let's try, console log, and I'll say describe enemies. And because this is just returning the string, right? I have to actually print it if I want to see the result that's returned. So I'm going to call describe enemies inside this console.log call. So I'm calling a function inside another function. Look at that. Moblin 1, and we'll say snarling menacingly. Okay. And I can run this. And we get a moblin is snarling menacingly nearby. Okay. So it took our, description, all the things we passed in, and created this sentence, and then we printed the result. So let's do it again, but we're going to run into a problem in a minute. So I'm going to copy this down, and I'm just going to change these values. I'm going to say, let's do a tektite, and say we have 3, and we'll have the action verb be hopping around. Okay, so if I run this again, we see both. And it just says a tektite is hopping around nearby. Well, we have a problem now because we actually said there were supposed to be 3 tektites, right? So we need to have a little bit extra. So in the process of, developing this, we're realizing, hey, I need to actually change my function definition to work for both 1 or more. So in this case, I'm going to just say, I need to update the value of enemy type to make sure it's clear if we actually have a group of enemies. And so what will work in terms of English syntax is we'll just say if the number of enemies is greater than 1, we're going to change the value of enemy type to something like, I need to update this. Yep, okay. Change my solution, and then I forgot to update the thing. Okay. Group of num enemies and enemy type. So we'll take the enemy type and actually say a group of that many enemy type. And now that that's been updated, it'll just read in the same sentence that we're returning, no problem. But that'll only happen if there's more than one, because we're using some conditional logic here, right? So let's run it again for these 2 console logs we've already got. And now we see 2 different results. A moblin is snarling menacingly nearby, and a group of 3 tektites, oh, I forgot the S, is hopping around nearby. Let's fix that. So I can just add a little S in here, and that'll make it plural. Yeah, a group of 3 tektites is hopping around nearby. Okay, so we have a piece of reusable code that we can use for a number of different things and have very different details, but it comes out the way we want it to come out every single time. We can count on it and just use it wherever we need to. And you can imagine that if you were coding a text adventure, version of Legend of Zelda, that this would be, it would come out, right? You'd want to have this kind of capability. So let me do one more example of how you might use this. It might be that you actually want to store it in a variable. So I could say let octorock description, and we'll say let's call describe enemies, pass in octorock and 4 and spitting rocks, and then we will print the result that is stored in that variable. And we can see it, a group of 4 octorocks is spitting rocks nearby. Okay. So those are a couple different ways. In this case, we went and got the return value and we just printed it, but we didn't save it. And here we actually stored it in a variable, which means if you needed to use it more than once at that point, that specific result, you could use it more than once because you stored it. All right. So there's one more way that you can do parameters here to actually make your functions a little bit more flexible. You could have optional parameters. And this only works if you can assign a default value when you define the function. So I have this definition, get full name. I pass in a first name and a last name, and I say this person may have a title, they may not. I need to make my function flexible enough to where I can handle that. So I'll say, okay, let's, we're going to build the first name by putting the first name and last name together. But we need to make sure that the full name has the title at the beginning, if there is a title. So the first thing I'm going to do, and I'm doing a little bit of string building here, just without a loop. I don't need a loop. We'll start with an empty string. We'll say if the title is not blank, because we've given it that default value up here. So it'll definitely be blank, even if it's not used. Or you could just say if title, because that would be, truthy or falsy. And then you can just add it to the full name with a space after it if it exists. If this has been left off and we actually are just calling it with a first name and last name and not passing in anything for this because it's optional, then it's going to skip this conditional logic because it's still just an empty string. And then it will only add the first name and last name. Otherwise, it'll add this after this, right? So we're just doing some things in sequence, and we have a little bit of logic to handle both cases. There is a title, there's not a title. And in the end, we have a full name that we can work with that may have been built one way or another way. So here's some examples. We want to go ahead and just use all three parameters. So I'm going to pass in arguments, Jane, Smith, and Doctor. And what would I expect to see the value of that returned?
Dr. Jane Smith.
Yeah. Okay. On the other hand, let's say I leave off the third one and I just pass in Bob and Jones. What am I going to see?
Bob Jones.
Yeah, Bob Jones. There's no title. Oops. There's no title. So because of the way I wrote my code, I said, if there's no title, then, then this will not be true. This will not execute, and we're just going to skip it. And so it just puts together the first and the last. So this is a flexible function. Let's go over and I want to talk about output. Do I want to talk about output? Yes. Okay. So let's talk about output, and then I'm going to do some more live coding. Okay. I mentioned before that you can return a value, or you cannot return a value. It just depends on what the job is for your function, what you need it to do. So if it returns a value, then you need to do something with it, even if it's just printing it, but you need to do something with it. Very common scenarios, you could store it in a variable. You could log it directly to the console. You could use it as part of an expression or a template literal and just go ahead and call the function and get what you need, and boom, it puts it right in place, right? So here's some different examples of how we might do that. Let's say I've got a function, I've defined it with the function keyword, I've given it a name, add 3 nums, I've created 3 parameters to be used, and I just say return num1 plus num2 plus num3. I'm adding 3 numbers together. Very silly example, but it'll serve our purpose, right? Here's one thing you could do with it. You could store it in a variable. You could say let sum of 3, and then use the assignment operator here, and then call the function, pass in those 3 numbers as arguments, and then get that value back, which is now going to be stored in a sum of 3. And now, so we would say the sum is, and what would we expect to see the rest of that sentence be?
9.
Yeah, the sum is 9 because it went to our function and it returned 2 plus 6 plus 8, plus 1. So that's where we put our function to work, called it, and stored it. Or as you've seen me do already, we could, just console log and just have 3 numbers and just print that result. And of course, then we would see 57, right? Would just come out in the console, but we didn't save it. We didn't store it. Or you can just put it right where you need it. Let's say we're writing a whole sentence. The sum of 8, 27, and 5 is, and then we call add 3 nums and get that back as 40. So our sentence would just read the sum of 8, 27, and 5 is 40. Okay. So the idea here in this case is that we had a function that returned values and we needed to do something with it. What if you have a function that doesn't return values? Yeah, here. So that return keyword is totally optional. You may not need to return a value. And some of the functions you've already used that don't necessarily need to return a value would be something like, reverse or sort, right? They go and they just do something for you. Console log is like a great example. It goes and it does something for you. It does not necessarily return anything. So functions don't need to return a value, and so then that return keyword is optional. So let's say you are just changing the value of an existing variable, like the contents of an array, or toggling a Boolean from true or false. If that's all you need to do, then there's no reason to return anything. You just make it happen. You could log a message to the console. We've mentioned that, yeah. And maybe you write a function to log a message and format it a certain way, and that's all it does. So let's create, oh yeah, one more. Triggering another function conditionally. You might have a function just to decide whether you need to call another function. This depends on what you need. So let's say we have 2 variables here. We have all prep work, and that's an array that you're going to keep track of all the prep work you've done. And started prep work is false. And so we start out and we say, I want to have a function that is to submit my prep work, and I say what that work is. And whenever I do that, I push that value into all prep work, so it's stored in the array, and I change started prep work to true, so it's clear that I have actually started. I can call submit prep work and pass in reading. Then I can console log started prep work. What would I see?
True.
Yeah, because one of the things my function accomplished for me was to change that to true, right? So let's say then I submit prep work and I submit exercises and I console log all prep work. What am I going to see for that?
Reading and exercises.
Yeah, I called the function twice. I gave it a different value each time, and each time it was called, it pushed that work into the array. And so now, because I've called it twice with 2 different values, that array has both of those values in it. So this is an example where you just need to put a function to work for you to change some values you already have. But it doesn't need to return a value. You're not looking for something to come back from it. Okay, we're going to do an example here where we have an inventory. So in a game, of course, you have an inventory of things that your characters, carrying around with them. We're going to add some things to inventory. We need to write a function to handle that for us. So I'm going to say, function add item to inventory and just say, okay, the first thing I want to do is anytime I pass an item in to this function, I want to push it to that inventory array that I'm using to store all the items. Also, just to have a little bit of feedback for the user, I will say link now has and we'll have an item of some kind, right? And so that'll actually, do it. So let's add a sword and a shield and then print that so we can see the result. Okay, so I can run it right now and it says link now has a sword. Okay, so I called it and it pushed it into inventory. We haven't proven that yet, but it's supposed to have. But it definitely console logged, this second line, right? So let's do one more. And I'm going to pass in a shield. And then I will actually print the value of inventory just so we can see what's in there. All right, we have Link now has a sword, Link now has a shield, and then of course inventory is now holding both the sword and the shield. So if you were coding a little video game, this might be exactly how you do this. You keep track of the inventory by adding it into a list that will store everything. And I'm also giving the user feedback because this is a text version of this game, right? Okay. So the last thing, oh yeah. So one more thing to know about how this works with output. You can stop a function early if you want to using the return keyword because it will always stop the function. Once that it comes across return, it just exits the function. So if you have some reason why you'd want to execute a function early, just use return in more than one place. You can have your final return, but you can also have an early return is a very common term for that. So you're going to hear me say that. I'm going to talk about an early return where we just say, let's just go ahead and stop the function now because we know what we need to do. Then, if that condition is not met, it's just going to continue on to the final return, right? So let's say we're dividing numbers and we, could just return num1 divided by num2, no problem. But what if that first number is, or the second number is 0? We can't divide by 0, right? So instead, we're going to return a little sentence and see how JavaScript handles that. And I think you can probably see already if you know your Toy Story where this is going. Okay, so let's say I console log the return value of divide nums and I pass in 6 and 3. What is that return value going to be?
Two.
Yeah, it'll just be 2, right? What if I pass in 4 and 0? What's the return value from the function then?
To infinity and beyond.
Yeah, JavaScript actually returns it as infinity when you try to do this. So it'll literally say to infinity and beyond if we were to do this. So that's just, us having a little bit of fun with error handling. But yeah, you can't divide by 0. So there you go. That's an early return. We just returned this and then it did not even continue to try to return this. Okay. Does anybody have any questions about what I've talked about so far?
Looks like no.
Okay. All right, then let's talk about variable scope. We got a couple more things to talk about, and then we're going to take a break. Okay, so variable scope is very important when you're working with functions, and other things too, like loops and conditionals. There's this idea of having local variables. So it's certainly normal to use variables in your function that were declared outside the function. Those would be global. We call those global. But a parameter has local scope, and so it can't be accessed from outside the function. When you create those parameters as part of your function definition, it's absolutely restricted to be inside here. So if you declare a variable inside the function with the keyword let, that variable is also local to that function. You cannot access it from outside the function. So if we have a series of lines of code here, let name equal Ella, and then I have function, greet user, and message. I'm going to pass in a message. I'm going to create another variable inside the function here called greeting and say message, comma, name. And then my function also will just print that. I'm not really returning anything here. I'm just printing it. So I call greet user and say good morning. What am I going to see?
Good morning, Ella.
Yeah. Good morning, Ella. Okay, so it made use of the message that I passed in. It also made use of the global variable name that existed outside the function. It has access to that. But what happens when we try here to console log name? That's no problem, right? We would get Ella. But if we try to console log message or console log greeting, Neither of those are available to us because parameters and anything declared with let inside the function is not accessible from the outside. Okay, so let's do a quick example of this. Let's ask the user to give us their name. Let player equal input.question. Please enter your name. Okay. And then we will have a function. Hold on. Yeah, down here. Okay. We're going to have a function to greet the player with a message. So we're going to do something very similar to what you just saw. Let greeting equal message. Forgot my curly brace. There we go. And then another one with a placeholder player. And then we'll just print that. That's the job of the function, is to greet them. So we'll greet them. Okay. So there's no return value here. So all we have to do is, we don't need to console log the result of the function because we're not returning anything. It does the console logging for us. So all I have to do is call the function, greet player. And I'll pass in a message and say, you know, good morning. How's that? Okay. So we can run that, and I'll enter my name. And it says, good morning, Carrie. Okay. So the function works. I can check the scope of player by printing it here. And we'll run that. And it runs it, and it's no problem because I actually declared player outside of the function here, right? But if I try to see message and greeting, we're actually going to see what does JavaScript have to say about this when we try to do this, right? Okay, I get an error. It actually crashes the program. It says message is not defined. So it tried to print message and couldn't find it. And so it's a reference error and we have a problem. So I say, okay, I can't do that. I'm going to comment that out. And now that we've done that, I can run it again. And it crashes again because I tried again to access something and now it didn't get stuck on message. So it continued on to the next line, but now it's stuck on greeting. So same thing, message and greeting are not available out here because they only exist inside that function. So that's going to be very important for you to remember when you're defining your functions and deciding where you declare variables. Do you need them outside the function or do you only need them inside the function? Okay, so let's see, I think I have one more thing here. Oh yes, there's the concept of variable shadowing, where you can have a local variable that has the same name as a variable that was declared outside the function, which we can loosely call a global variable. So if they have the same name, it could cause conflicts. JavaScript does handle it a particular way. It'll allow it because it makes a decision on which one it's going to choose. So let's say we have a color set to black and we say I want to describe an item and I want to allow this function to take both an item and a color. And then I console log, it's a color item. So let's say I call describe item and I pass in box and blue. What do you think that I'm going to get?
It's a blue box.
Yeah, it's going to actually, JavaScript will use the local one in favor instead of the global one. But if I console log color right now, what do I see?
Black.
Yeah, because it doesn't have access to the parameter that exists only inside the function. So generally speaking, this is a bad practice. Don't do it. It's better to have clarity and prevent confusion for yourself and for others. So you could name it anything you want other than having them both named color. You could be more specific about, I don't know, it depends on what you're describing, right? Box color or whatever it is. Just choose a slightly different name so that it's, now if you have I get this question from students. What if you have a whole lot of functions that do different things with the same information? Can you have several functions defined that all have a parameter called color? Absolutely, because those are mutually exclusive, right? They're local to each of their functions. So that would make sense to just use color for all of them. But if it exists outside the function, that's where it's declared and used. Don't give it the same name. All right, so last example here, we have a name, Zelda. And we're going to write a function that will announce the character of who it is you're meeting. So I'm going to say function, announce character, name. We'll pass in a name and console log. You meet name as you walk through the door. Okay. And so we can call the function. It prints for us, so I only need to call it announce character. And let's just pass in Gannon for the name. And oh, I'm skipping ahead. Okay, I want to call it with name as the variable name. Anybody want to guess what I'm going to get?
I heard Zelda.
Yeah. There we go. Okay. Oh, I have to skip past this one. Hang on. Yeah, you meet Zelda as you walk through the door. So, I just used name as a variable, and it has the exact same name as the parameter variable here, but it's because I'm using it from here, it goes and looks for it outside the function and it finds it and says, oh yeah, I can use that, no problem. But if I want something different, I'm calling it here, I can actually pass in a hard-coded string like Gannon. And now when I run it, will you meet Gannon as you walk through the door? It chose the local one at that point because I actually gave it a hard-coded string and not a variable that existed outside. And then of course, if we print name at this point, the only thing that's stored in the variable name globally is Zelda. So that's what we see. So again, it would be a better practice not to do it this way. It would be better to have like, princess or something like that. And so you can use announce character and pass in princess and get the result that we saw there. Or you could use a hard-coded string. Your function will work either way, but it's just a bad practice to have the exact same variable name in both places. Okay, any last questions before we take our break?
I don't think so.
Okay, all right, we're going to take a 5-minute break. We will come back and talk about composing functions. And then I'm going to do a little demo for you of a little program. All right, welcome back. So function composition. The general idea with functions is that for the most part, they should have one job. You want to keep them very small. And we have this concept of like utility or helper functions that just do small little things you need them to do, and you can use them for a lot of different things. But then you can have one big main function to put it all together. And then just use your other functions to take care of all the small, specific little tasks that you want. You've already seen this structure with your graded assignment, right? You have smaller functions like, going and asking a question, or, that initial prompt where you're asking for the user's name, or you're grading the quiz. And then all of those are called from a big function run program, right? So this is typically a good structure to use for your files. Imports, variables, and data that you're going to use, and then some minor functions, and then that one last function that's going to run the program. And they don't have to be sequential, but usually functions are defined towards the end. So you just have to decide. The main advice is just to be organized, right? But if you put things in an organized kind of section them out this way, it'll be easy for you to find what you're looking for. It's easier for other people to find what they're looking for in your code. So this can generally be a good format to follow. So let's talk about this idea of composing functions where you use one function to help you with another function. You can break out smaller tasks into separate functions and then call that function from another function. And maybe it's for different reasons, right? To calculate and return some sort of value or request user input, like you're doing with your graded assignment. Validating user input, you could have a function just for that. Maybe you have things that you want to print to the console in a specific format. So you can go and have a function that you use consistently just for that. And so on and so forth. Lots of little ideas, things that you can create smaller functions for that will serve you in the big scheme of things. So here's an example where I have two functions. I have subtotal, which will, as a verb, which will go and take an array of numbers and, get that number, that sum for you of everything that's in that array. But ultimately, you plan, your goal is you're going to have multiple arrays of numbers, and you need to get subtotals of each one. So let's say you have to run a report on a couple of different divisions at your business, and you want to get their earnings, and each division has an array of numbers that represents it. You could say, okay, for the month of whatever, and pass in that month, and then have, division 1 and division 2's numbers. And then go and use subtotal, call that function from here and pass in the first array, and then call it again and pass in the second array. Store those in variables that represent the total earnings for each division. And then your final statement that you're returning will use those values and then use them again. You can say in the month, division 1 had, div 1 in earnings, while division 2 had div 2 in earnings. Total earnings was, and then you can say div 1 plus div 2. So that is an example of using a smaller function multiple times in this case to to do one job so that you can have another function do a bigger job. I've had people ask before, why the double dollar signs? That's just because the syntax for a placeholder needs $1 but I actually want a real dollar sign to show up in my final printout, right? So I have a dollar sign ahead of my money, but it still evaluates the second dollar sign with the curly braces as the placeholder for a template literal. Okay. So I'm not gonna live code anything for this. I just wanted to go over it as a concept. So let's just kind of recap. There are so many reasons why functions are awesome. They are reusable, right? You can have very dry code and not have, a ton of repetition. Remember, dry stands for don't repeat yourself, right? And you also can use it in multiple locations. We are pretty soon going to learn about modules. You've already seen them in action where LaunchCode has set up files like your graded assignment with multiple files, and it's like importing and exporting things from those files. Those are modules. Those are JavaScript modules. So, it's very common to put a bunch of functions that you can use anywhere in your application and go store them in a file and then just access them from there. For readability purposes, a function should really have that single purpose. So it makes it, you don't have to wade through a ton of code to figure out what all is this function doing, because it's doing like 3 different things. You want to have a very clear name, make it very clear what that function is responsible for. So, you could have a function like this, and this is a very common real world example. You want to format a phone number. So first of all, maybe it comes in as a number, so you need to format it as a string so that you can use the slice method, which is a string method, and then take a slice to get the area code and a slice to get the exchange, the rest of it. No, just the middle part. And then the line, the last 4 digits, right? So I could use slice 3 times to break that up and get the parts that I need from that, and then return it formatted exactly as I want. And you can imagine that a really big business might have a website where they're going to be displaying phone numbers in different places all over the website, depending on what department it is or whatever. And if you want to be really consistent about your formatting, we always want to format our numbers this way. You can have a function like this that can be used as many times as you need it and in as many different places as you need it. And you would get the consistent results. And then maybe later down the road, some designer comes along and changes the website entirely. And they say, we don't want to use parentheses anymore. We just want to use dots between, the three parts or whatever. No problem. You come in here and you change that one line of code and it updates everywhere because everything is depending on just this one little function to format things consistently. That's why functions are awesome. So yeah, you might use it on a profile page, a company contact page, anywhere you want that, right? Okay. Does anybody have questions about this stuff that I just talked about before I do this demo?
No.
Nope. Okay, good. All right. So what I've got here is a little like miniature first couple of moments of Legend of Zelda, the original, 1985 version. I think it was 95, something like that. I'm sorry, 85. Trippin'. I played it in 1986, so it had to be 85 and not 95, right? Okay, so what we're going to do is we're going to start at the top with our imports. In this case, I'm importing the readline sync library. My next section is data. So I have some initial values of things. Max hearts is 3. Current hearts is 3. Inventory is nothing. The number of rupees gathered, the coins, nothing. And then I have this line that I want to use to format my text. So I'm going to use that a whole bunch. And I've just taken a hyphen and used the string method repeat to say, give me 80 hyphens in a row. And then I didn't have to hard code that. And then I have some conversations that I might have with certain non-player characters. So, the old man says, it's dangerous to go alone, take this, before he gives you the sword. And you go into a shop, buy something, will you? And you can buy a magic shield for 160 rupees and so on and so forth. Okay, so we're going to make use of this data, and I've got that right up here at the top, so I can just use it where I need to. Because this does have to be at the top for you to use it anywhere below. A function can be used from anywhere, but JavaScript's still going to read this from the top down. So that's generally why we want all this stuff to be at the top. All right, then I'm going to have a section where I have a bunch of minor function definitions. I'm going to add all these for you as we go. Down here is my main function, run program. Very common name because it makes sense, right? And right now, my entire program is written inside run program, and it's kind of it's busy. There's very little going on because, you can imagine this is a huge game and we're only going to do like a couple moments, but it's already like 65 lines long just because I keep repeating certain sequences with the code over and over again just by coding it one line at a time and expecting it just to run from top to bottom. We're going to change that. We're going to clean this up. We're going to find where we have code that can be reused and we can move those into some smaller functions. So I can run this now if I want to. That's not what I want. There we go. All right. So it's printing a description for us. It's 1986 and the kingdom of Hyrule is in chaos. The evil prince of darkness, Ganon, has stolen the Triforce of Power and is holding Princess Zelda captive in Death Mountain. Link, you must gather the 8 pieces of the Triforce of Wisdom, defeat Ganon, and rescue the princess. Only then can order be restored to Hyrule. All right. Link sees a cave opening in front of him. Would you like Link to enter? Yes or no? So we could enter the cave, and then we get an error because I'm referring to things that don't exist. Okay, so we're already starting to run into some problems because I have some things in my code where I started to change it to make it a little bit more reusable, but that doesn't exist. It's not even hard coded in there. So let's start cleaning this up, and we will figure out how to do this a little bit at a time and move some of these things out of run programs so that we can have other functions that just handle those jobs for us. The very first one I want to do is to, sorry, give me just a second. There we go. The very first one I want to do is to describe Hyrule. So we're going to have a function that's just going to take care of this. So I'm going to take this out of here. I'm going to just cut that out and come up here and define a function to do it for us. So I'll use the function keyword, give it a name, describe Hyrule. And then I'll just add my code. And that's all it needs to do is just print that for us. And that's that function's job. And now we have, instead, we can come down here and run program and just say, describe Hyrule and call it, and it will work. And if we run the program again, we see it, right? So it's still doing it for us, but we've taken it out of there and, you know, moved it into a function. Okay, let's do it again. This is where, you know, I have this, let's see, gotta find it. Yeah. I have this stuff I started to write where I could like maybe have different characters doing things, but you know, care and message don't exist right now. An item doesn't exist. What I really need is actually, you know, I've got some good code here that could be reusable, but I need to put it into a function in order for it to, and actually I have two different things here. Okay. First, I'm asking the question, would you like Link to enter yes or no? That in itself is actually a much smaller thing, right? And then we have some logic about, you know, if the response is yes, if the response is, you know, then we would do this thing, otherwise we won't. So let's just actually handle just this part of getting the response and saying, you know, we're gonna see some sort of character and we're gonna have some sort of message, and we'll just handle this one little part here. I'm gonna move this out and pull it up here and have a function that takes the character and the message. I'll call it get character response. And I'm gonna return that string instead of console logging it. I just want to actually want the string. But the other thing is here, I already see some repeated code here as well, where I've got these long lines, right? But I've defined this reusable text that I can use instead. So as part of this template literal, I'm just going to take that hard-coded line and remove it and put a placeholder in and just say line instead. And then I can do that again and use it in both places. And now I can be consistent. If I ever decide that I want to change the formatting, you can imagine I might have used that line in 100 different places. I only have to change it here, and it's now going to be consistent everywhere. So, so we're cleaning things up a little bit, right? So now, towards the bottom, if I have this, you know, initial part where in run program where I'm saying Link sees a cave opening in front of him. Would you like Link to enter yes or no? So we have yet another thing here that we could probably, you know, it's possible that we could have multiple caves that we want Link to enter. So maybe we don't want to have to ask this, you know, over and over again. We could actually move this out as well. So I'm going to jump around just a little bit because there's a number of different things that we can do. Let's write one called enter cave or skip. Yeah. All right. I'm doing these, I think, not necessarily in the same order I've done in the past, but that's okay. It's all going to come out. And I think I want to just stop for a second and just qualify what I'm about to do. This is going to get complicated relative for you as a beginner. This is going to look complicated real fast. I don't expect you to understand everything I'm doing. Just follow along with this you can. My goal is just to inspire you to see how cool functions can be, to write cool little programs, so that maybe as you get into this and you do start to get comfortable using them, you can go experiment on your own. Okay. So I'm going to say I want to either enter the cave or I want to skip. If I do enter the cave, then I need to know who the character is inside, what their message is. And if they're giving me an item, I can do that as well. Okay, so let's move our response. Right now we have, this whole thing. And we're saying, let response equal, we're asking the question. Let's go ahead and just do this. And I'm just going to change it to response because I don't need a response 1 and a response 2, et cetera, if I'm going to make this reusable. So we'll do that. And then we'll just check and say, if the response, and I'm going to make sure that, maybe they didn't put in a capital Y or N. So I'm going to make it uppercase before I check it. It's always a good idea. And I can say if it's Y, then we want to, go ahead and console log that message. And this is where we can actually call our other function, get character response, and pass in the character and message. Okay. So that's part 1, but we also have this other part here. Okay, so I can take this out as long as I replace it, right? So I can call enter cave or skip here. And pass in an old man sword message, which I've already defined at the top, which was the one that's, it's dangerous to go alone, take this. And pass in the sword as the item. And then we have a little bit of logic of, what if they say yes, then we push that item. We already have a little bit of logic here just in terms of getting that response. So we might as well have a way to handle inventory addition as well. So that anytime he has any sort of items that get added to his inventory, we can just push that and then print this little thing as a response. And that could happen lots of times. So let's move that into a function as well. I'm going to come up towards the top here. There's an instruction right here to define a function that adds an item to inventory. So let's do that. And this one will be reusable. You can use it for lots of different things. Okay. And I already have this, but I'll just retype it. It's okay. Link now has a item. Okay. All right. So now that we've done that, we could, come back to our run program and say, we can replace this now that we're, pushing the item and logging this, but it's still dependent on this logic. So really the best place to put this would actually be inside enter cave or skip where we're handling that logic already. So I'm going to just remove it from here and let this one handle it and say, if response is Y, then not only do we go get that character response, we also check to see if there's an item. Actually, no, we're not there yet. We add item to inventory. Okay. The thing about this is you may occasionally have situations where somebody goes into the cave and they might even have a conversation, listen to what the character has to say, but maybe there's no item, right? So we can make item an optional parameter here and let it be left off if there is no item. So if we're going to do that, then we need to have a little logic here. That's what I was getting at a second ago. And then just put this inside it to where we only add item if there is an item. Otherwise, if that's empty, it's going to, this is truthy falsy, it's going to resolve to false. And it won't do this. Okay, so we have, this function is using 2 other functions that we already defined above to handle 2 little small jobs. And then together it's handling a job that we could potentially repeat over and over. And so, we've got our first instances of this here. Okay. We have another place later where we have another cave that Link could consider heading into. So this is another opportunity where we could then use these again. So if I come down here and, at this point in the program and say Link considers heading into the cave when he sees this cave opening, we could ask the user if the link should go into the second cave. We already have a function for that. So I can just say enter cave or skip, and this time give different information, the shop owner, and then shop message. But at this point, your character doesn't automatically get an item, so I'm going to leave that out so that it doesn't include the item. It only is going to display the message instead. So we're going to see that when we run this again, we're going to see all of this come up. But we still have quite a lot to do here. We've got, instances where Link runs into enemies, and the question is, will he fight? Yes or no, right? And if he does, he attacks, and then he has, there's an opportunity for the enemy to possibly hit him. So he's dodging the enemy. Even if he doesn't attack and says no, we're still going to have, say, oh, he's got to get through there without getting hit. So he's going to attempt to dodge the enemy. And so we have this exact same logic of, if we have a very small, 20% chance here, random number that he gets hit, then we're going to decrease his current hearts and by a half a heart. And we're going to say that he lost a half a heart, and then also update the player on how many hearts he has remaining. Otherwise, we're going to say, phew, it missed, right? I just did this twice because I'm dodging if I'm fighting, but I'm also dodging even if I choose not to fight. So we obviously have some things here that we could clean up. And then later on, I would like for him to also consider fighting these Octoroks that he runs into. Then I have to run this entire sequence again. So let's go ahead and define some more functions to handle fighting and dodging. And then we're going to be able to clean this up considerably and just pass in different information depending on what enemies it is that we're talking about. So I'm going to come up here and into my smaller function section. And dodge enemy is clearly something that we need to have whether he chooses to fight or not. So let's do this. We'll write a function, dodge enemy. And we're going to say the enemy type. We need to know the enemy type. We also need to know how many enemies. This is going to look really similar to, what I was kind of doing before. So we don't know how many enemies there are right now that will be passed in. So we could definitely, and we also have, we could use a for loop or we could use a while loop. I'm going to choose in this case to use a while loop and count down. So we're just going to decrease the number of enemies. That number already exists for us. So why don't we just decrease it each time and say, while the number of enemies is greater than 0, we'll keep running this and we'll just keep decreasing them. So if math.random, and this is where actually, let me just go get, we have this already, right? So let's just grab it. We can take this, for example, and paste this into here. And then all we have to do is just fix it so that it uses the actual information. Like right here, instead of the tech type, we can make this usable for any enemy type by putting a placeholder in there. But then we also need to we need to have that update expression. We need to decrease the number of enemies every time he either gets hit or he doesn't, but we're going to decrease it and basically give each enemy one chance to hit him while he's moving through the room. That's going to be our idea here, or why he's fighting them. Just for some, simplicity's sake, that's what we're going to decide to do for now, because this is a text version. Okay. So we have the same exact thing. Now we can actually go and replace our code below with dodge enemy. So right here where he tries to dodge, let's just, call it from here and say dodge enemy and pass in tech tights, or tech tight singular, and say he's dodging 4 of them, okay? And then we can also do it here again. Otherwise, he tries to dodge the enemy, even if he doesn't fight. So we'll use it again. Same thing, tech tight or 4. Now you could even make this cleaner by just taking this out altogether and just putting it outside of this and saying, no matter what happens, we're just gonna do this after. So I could actually take it out of here and just put it right here afterward and not even have it in an else statement because we're basically saying we want it to happen either way. The difference is going to be like kind of how we decide to sequence it in terms of, you know, him fighting multiple ones. So we may have to clean this up and change it further, but we're getting there, right? Okay. So dodging the enemy is one thing. What about attacking the enemy? And deciding to fight? You know, we give the user the choice whether they want to fight or not. Let's take care of the attacking. Let's just do the fight enemy part, and then we will keep going from there. Okay, so right here, I can say function fight enemy. And then we're going to have a kind of one size fits all thing here where we pass in the enemy type and say, you know, same information, num enemies. Let me spell it right though. There we go. And we'll just say, you know, while num enemies, and we can do this very similarly to this actually in terms of the while loop, but it's just the actions that are going to happen inside that matter. And so I can take out this part where we're dodging and just go back down and say, okay, we've got this other stuff going on where he's attacking, right? So why don't I just say, you know, he attacks, that's one, you know, enemy down, and then we'll go from there. Okay. This one line is really all that I want so far. So I'll come up here and put that in, and we'll just change this to be enemy type so that it's one size fits all. Okay. So he attacks, it's an enemy down, and then we, you know, try for the next one. But we also said that, you know, there's going to be a chance here for him to dodge the enemy. This is where we can just make use of dodging and give it whatever the enemy type is and the current number of enemies. And every time this loops around, it's going to lower that number. And he's going to have to go through and dodge all of them again, however many are left. Let's say for now that he always hits them. So, you know, we're just going to assume that every time he attacks, he hits them. It's going to keep our program simple because we're only doing a little bit of this, right? So obviously, if you were to make this fuller and have a chance, you'd have to, you know, add some more code. We also know that Link had the option to either go into that first cave or not go into that first cave. And what happens if he never went into it and then he encounters an enemy and he never got his sword? We're just going to say he can't really, you know, fight them without it. So we're going to go to the inventory and see if it includes the sword. And if it does, oh, no. If it doesn't, because we're negating it with the bang up front, right? So if it doesn't include the sword, we're going to say console.log Link cannot attack without a sword. And then we'll have him dodge the enemy anyway so that he can try not to die. And we'll just pass along that same enemy type and the num enemies. And then we're going to do an early return. So this is an example where we come in here, we do not want the code to continue because we don't really want to go through the attack sequence if he's just going to, at that point, try to dodge them and just try to get away because he doesn't have a sword. So we have a little bit of logic here with a possible early return only if he doesn't have the sword. Otherwise, we're going to let him fight. And so he's going to attack and then he's going to dodge, and we'll keep decreasing and going through that sequence. All right, so now we need to update our run program to use this. Right here where we say he attacks, right? So we'll say, you know, fight, hold on, fight enemy, and then pass in tech type and 4. Okay, so same enemy here, the 4 tektites, and down here he's trying to dodge them afterward, which, you know, we now have kind of handled the before and after of that. Have we, if he says yes, no. Oh yeah, we need to ask if he even wants to fight, right? So let's have a function just to handle the decision if he chooses to fight, because we haven't even really done that, and that's going to matter. Did I mention that this is going to get a little bit big and possibly overwhelming? Yeah. Okay. We're going to write something called fight or dodge, where he just decides what he's going to do. And that's going to help us control this logic of whether he even fights or not. So we'll say function fight or dodge. And we'll pass in the enemy type and the num enemies, because whichever function we end up using, the fight or the dodge function, we need that same information, right? We'll just pass it along. So here's where we go and we have this question, will link fight, yes or no? So I can remove this and set this in here and just say, let response equal, will link fight, yes or no? And then we can have this decision. So if response is yes, he fights the enemy, and then otherwise we were having him dodge. So let's actually just take all of this out. And we're going to handle this part about him possibly having rewards in just a second. But for now, let's come up here and remove this. And now we're going to handle both the fighting and the dodging from here. And we only have to call the one function and run program. So if response dot to uppercase equals y, then fight enemy and pass along the enemy type and the num enemies that were passed in above. Otherwise, dodge. And we already had fight enemy take care of when he's dodging while he's fighting. So this will take care of when he chooses not to fight, right? So you already can see how having these all defined in separate functions gives us a lot of flexibility for reusing code in different circumstances. All right, so fight or dodge, that's all we really need now. So we're going to come down here and say fight or dodge. Let me get that. Fight or dodge, and we'll pass in tech types as the enemy type. Notice that VS Code is prompting me. It knows the definition of this function, and it's prompting me and telling me, here's the possible parameters that you could use, enemy type and num enemies, right? So I'll pass in tech type for enemy type, pass in 4 for the number of enemies, and that should handle that entire sequence for us. So this last little bit is going to be just to handle the rewards. We are giving him a chance at increasing his hearts. We're also giving him a chance to find a rupee. So we've got this logic here. I'm just going to pull this out and we're going to put it in its own function. So we'll have a function here called get reward. After the fight is over, they'll have a chance at getting a reward. So let chance equal, oh, actually, I already did this part. I can just paste it, right? Yeah. And this is just going to work with all of these values, these global values we already declared at the top: current hearts, max hearts, rupees. And it's going to access these, possibly update these numbers, but it all gets handled right here in get reward. And then all we have to do, and I need to fix this. There we go. My indenting. We just come down here now, get rid of that, and just say get reward. And just run it and let it happen. And it's going to take care of that, all of that possible sequence. But actually, the best place to ask for this would be in the fight sequence, because we only want to do it if he fights, right? We don't want to do it if he chose to dodge. So let's actually move this up to fight enemy and just say, if he actually chooses to fight, then we're going to run through this while loop here. And every time he defeats one, and since we're saying he always will when he attacks these early enemies, we're going to go ahead and let him get a reward from just that enemy. And then he'll be able, every time he fights and attacks and kills a new enemy, he'll have an opportunity for a reward. So we'll do it multiple times. And we'll let it happen before we dodge. How about that? Okay, so he attacks, and we're going to decrease the number of enemies, but we're also going to, and really we should be decreasing the number of enemies before we dodge them, right? If he already has killed one. So let's do that. Let's decrease num enemies and then pass it in. Okay. So I think we're almost there. We really, we've got entering the cave, fighting or dodging the tektites. Now he walks north and sees another cave opening. And so we can ask him if he wants to fight the Octoroks. So all we have to do now is go back to fight or dodge and pass in new information and say Octorok and there are 4 Octoroks that he might fight. After that fight sequence is over and he's collected any sort of, rupees or hearts or whatever, we move on. He considers heading into the cave that he sees here. So now we can enter the cave or skip with the shop owner, have that message. And then we have this last line that is just going to say he doesn't have any money to do any shopping yet because he needs to get back to doing some more fighting. And we're just going to end it here because this is as much as we can do for now, right? So all I need to do now down here is execute my program and run the program. Keep in mind all this code that I put in here inside run program, and notice how short that is now. It all fits here just in a few lines. This defines run program, it does not execute it. And since I'm not using multiple files, that means I need to run the program. And so I'm just going to do that last. I'm just going to say run program. All right, so let's do it. Let's go through this. I'm going to cancel out of this and rerun it. And I have an unexpected token on line 66. So you're going to see me do some debugging. All right, line 66. Let's go find it. Get reward, open, chance equal. Oh, yeah. I think we have some logic here. This one opens here, closes here. This one opens here, closes here. That's not where the problem is. The problem is somewhere else. Oh, this is one.
It needs function in front of it on line 66.
Awesome. Good catch. Thank you. I was coding some classes the other day, and when you code classes, you don't put function in front of it. So that's probably where my brain was at. Okay, so yes, function, good catch. I'm glad you guys caught that. Okay, so now we should be good. Unless there's other mistakes, we'll find out. Okay, no, we're good. Would you like a link to enter? Yes or no? Let me pull this up a little bit. Yes, I definitely want to go get that sword, right? Link now has a sword. Link walks west and sees 4 tektites hopping around. Will Link fight? Yes or no? Let's do it. Let's fight. Okay, so he attacks. That's 1 tektite down. Now he dodges them and they all miss. He attacks. He kills another one. But now a couple of them actually manage to get some hits in. So he loses a couple of half hearts and now he has 2 hearts remaining. Attacks again. And this time he actually, he had a chance to get a reward and he, got a rupee. Kills another one and he found a heart. So now he's got another heart back and he has 3 hearts again. So now he heads north, sees another cave opening, but 4 Octoroks are coming at him quickly. Will he fight? Yes or no? Let's say no this time and we'll try to dodge them. And he manages to dodge all of them and get inside the cave. And so we'll say yes. So now he sees the shop owner standing before him saying, buy something, will ya? And but he doesn't have enough money. Okay, so we've just run through that whole sequence and we had a number of different things that happened in different ways multiple times. And we used our code over and over again to make that happen. By defining it all in separate functions. So again, I know this was probably a little bit overwhelming. This is not expected to be something that you would be able to go out and code anytime soon. But I just wanted to show you kind of where you can go with this. Now that you know how to write functions, you're going to get better and better at it. And ultimately, you could play around with trying to write a little program like this, where you've got a lot of different functions doing different jobs and then bringing it all together to run it from top to bottom. And really, I mean, you are going to be doing that for your graded assignment. It's just already been set up for you. You're not having to, design it from scratch. Okay. Does anybody have any last questions about any of that?
Don't think so.
Okay. And all of that code is, of course, in the solution branch of my repo for my lecture examples. If you would like to go back and refer to it at any time, or even run it and mess around with it. Okay, so I have lots of practice exercises for functions if you would like to go and work with those to give yourself a little bit more practice. And then, of course, again, GA prep for graded assignment 1. If you have time, you could go check those out. All right, tomorrow is a graded assignment workday, and there will be a review session after lunch. But part 2 of graded assignment, you want to definitely try to get that in by the end of the day to stay on target. And then we'll talk about functions and kind of unpack a few more things about functions because there is more to learn on Thursday. And then Friday, you'll have that self-assessment exam, your graded assignments due, and that's your big deadline. Monday, we will talk about objects, and you're going to learn how to create your own objects. That's going to give you a lot more flexibility with designing programs with your code as well. So it'll be good stuff. For Studio today, you're going to compose some functions. You're going to have something to reverse characters in a string. And then you're going to make sure it also works for digits if they're part of a string. No, if it's a number. And then you're going to actually reverse a whole array of strings while also reversing the characters. So you're going to need one function to use in the other function over and over again as you work your way through the different strings in the array. So it's a very good exercise for learning how to do a lot of the things that we talked about today.